Let's talk about molecules. Okay, so molecules are combinations of elements or atoms. Okay, so any combination of atoms form molecules. So things like H2O, CO2, N2, CH4, these are all examples of molecules where you combine different or more than one atoms together form a molecule. And some molecules are called compounds. Compounds are molecules with different components. So must have different components to it. So for example, H2O is a molecule that's also a compound. However, something like oxygen, O2, is a molecule, but it's not a compound, all right? So a compound must have different atoms in the molecule. Now, there's something called the molecular formula, which is basically what we have right here, where we have the symbol along with subscripts to indicate how many of each element is in the molecule. So here, for example, C6H12O6 means that this molecule of glucose or fructose is composed of 6 carbons, right? 12 hydrogens and 6 oxygens. That's what makes up that molecule. So we write it as a molecular formula. There's also something called the structural formula. Okay, so the structural formula shows you how the molecule is put together. So it identifies, the bonds, the bond locations in the molecule. So for example, something like this. This is glucose. Something like this is fructose. This is glucose and fructose. And they both have the same formula of C6H12O6, but they are arranged differently. Okay, so the arrangements is what the structural formula shows you, even though they have the same molecular formulas. So molecules with the same molecular formula, but different structural arrangements or different structural formulas are called isomers of each other, calling them structural isomers. So for example, glucose and fructose are both C6H12O6, but they're arranged differently, so they're called structural isomers of each other, glucose and fructose. Okay. We also have the molecular weight then. The molecular weight of a molecule is the sum of each element in the molecule. For example, if you had, say, something like maybe something like carbonic acid, H2CO3. Okay, its molecular weight will be the weight of H of hydrogen, right, times 2, we have 2 of them, plus the weight of carbon times 1, because you only have 1 carbon, plus the weight of oxygen times 3, okay? So we know that hydrogen has a mass of 1 AMU. Carbon has a mass of 12 AMU. And oxygen has a mass of 16 AMU. Okay, so 2 times 1 will give you 2 for H's contribution. Carbon will contribute 12, and oxygen will contribute 48 to give you a total of 62 AMU. That is the molecular weight of carbonic acid. Okay, 62 AMU. Again, it's not 62 grams, it's 62 AMUs. One molecule of carbonic acid weighs 62 atomic mass units, not grams. Okay. Let's get on to chemical bonds. So these molecules, C6H12O6, H2CO3, CO2, H2, N2, these various molecules are held together by bonds, chemical bonds. So let's look at that next, the bonds that hold molecules together. And we'll look at 3 types of bonds. We'll look first at what we call your ionic bonds. Ionic bonds are bonds that hold ions together. Okay, so they hold ions together. For example, sodium ion with a charge of +1 is held together electromagnetically to chloride ions. All right, and this bond here is an ionic bond because it's holding this ion attached to this ion based on their attraction of charges between the plus and negative sides. Okay, this is an electromagnetic attraction, which is very powerful. In fact, this is what holds us together mostly. We don't fall into a puddle because our electrons are electromagnetically attracted to our protons in our nucleus. So we're held together that way. So it's a very, very powerful force. So again, ionic bonds hold together ions in a molecule. Then we have your covalent bonds. Covalent bonds are formed when electrons are shared between atoms. Okay, so from sharing electrons. And here, of course, you have something like, say, maybe oxygen will share an electron pair with hydrogen. Okay, so the sharing here, so each bond that's formed is based on the sharing of a pair of electrons. So each bond, so it's one pair of electrons shared there. Okay, so it's a single bond, a single. You may also have a situation where you may share 2 bonds. You may share 2 pairs of electrons. That's a double bond. A single bond where you share 1 pair of electrons, 2 pairs of electrons, double bond, and you also have cases where you share 3 pairs of electrons. Okay, triple bonds. All right, so covalent bonding is based on sharing pairs of electrons between the atoms in a binding pair. Sometimes these covalent bonds are polarized. Okay, so for example, with oxygen and hydrogen, oxygen is very electron greedy. Okay, it attracts electrons, especially in an effort to satisfy its octet requirements, and so it's said to be quite electronegative. So in this bond between oxygen and hydrogen, the electrons will spend more time over here than here. So the cloud of electrons will be bigger around the oxygen versus around the hydrogen. and that would give the electron a slightly more negative charge on oxygen and make it slightly positive. So in a covalent bond where the electrons spend more time on one side versus the other, it creates small charge differences across the bond. So this is called a polarized or polar covalent bond, where the electrons are not being equally shared. If they were being equally shared, for example, if you have, say, between carbon and carbon, right? These are the same identical atoms, so they're shared equally. So here there will be no different charge distribution across the bond because it's being equally shared. It spends equal time here and here. So these are called non-polar covalent bonds. You have polar covalent and non-polar covalent bonds, okay? Then we have a third type of bond called the hydrogen bond. Hydrogen bonds are formed between polarized molecules. So here we go. Here we have, for example, if you have, say, water, it's H2O, H here, H here. Remember that in these bonds, the oxygen gets most of the electrons, so it's charged slightly negative, while these are slightly positive because the electrons spend more time here than here. And so if you have another water molecule in the vicinity with the same polarity of pluses here, negatives here, these two will attract each other based again on the opposite charges, and normally indicated by a dashed line. So this dash bond between the hydrogen that's being polarized and the oxygen that's being polarized is called a hydrogen bond. Very weak bonds, but in great numbers, they can give you an overall strength that can hold things together very strongly so. Okay, so you have ionic bonds, covalent bonds, hydrogen bond. And usually the order in terms of strength of bonding, and this one is sometimes a bit controversial, but the rule of thumb is that covalent bonds are stronger than ionic bonds, which are stronger than hydrogen bonds, okay? Some books do actually go ionic bonds to covalent bonds to hydrogen bonds, okay? So these two are a bit unclear, and I need to really research more on that before I kind of make it, doctrine per se. But for sure, these two bonds are stronger than hydrogen bonds. Keep it at that level. And among the covalent bonds, non-polar covalent bond is stronger than polar covalent bonds. Okay. All right. So that's bonding between molecules, and we'll pause there.